Hey guys, this is a video solution to example tutorial sheet 12. There are 5 questions in total. I will go through every single one of them and give you a detailed solution. Once again, this is on top of the typed solution for this tutorial sheet, which you can find in the course website. So let's start with question 1. It has 2 parts. The first part is to test the hypothesis mu1 minus mu2, two population means equal to 0 versus greater than 0. So this tutorial sheet is on 2 sample tests of hypothesis. So if you look at the video for that, that will help. Okay, so let's start with part 1 of question 1. So we are trying to test whether mu1 is equal to mu2 versus the alternative that mu1 is greater than mu2. Okay. Now, once again, if you look at the video for this, the rejection rule is as follows. We reject H0 if the following is true: x bar 1, the sample mean for the first population, x bar 2, the sample mean for the second, divided by sigma 1 squared is the population variance for the first, which is actually given to us here, 6.25 and 9 respectively. Sigma 2 squared is the population variance for the second. And N1 and N2 are the sample sizes. Right, is greater than Z1 minus alpha. So this is the rule I gave you in the video, and it's also on the handwritten notes and also in the typed notes. Right. So what I'm going to do is I'm going to work out the left hand side and the right hand side and see whether this inequality is satisfied or not. Right. So let's start with the left hand side. X bar 1 is given is 11.4. Yeah. X bar 2 is 9.9. Divided by sigma 1 squared is 6.25. And N1 is 10, which is over here, right? Okay. Plus 9 divided by 12, square root of it. Right? So if you work this out using a calculator, you will get this to be 1.279. Okay, and and the right hand side, we are using 5% level of significance, so your Z1 minus alpha is 1 minus 0.05, which is Z 0.95. which is equal to 1.645. Alright, clearly this is less than, this is not greater than this. So the conclusion that we have is that there is no evidence against the null hypothesis. In other words, there's no evidence that the two population means are not equal. There is no evidence against the fact that the two population means are equal, right? Okay, so that completes the first part. The second part is what is the probability of the test if the true of correctly rejecting the test when the true difference in the population mean is equal to 2. All right. So this is question 1, part 2. So we are looking for the probability of rejecting the null hypothesis when the difference between the two population means is equal to 2. Okay. Now if you go back to question part 1, you see this is the rule for rejecting the null hypothesis. Okay. So I'm going to write that down one more time. So this is equal to x bar 1 minus x bar 2 divided by 6.25 divided by 10 plus 9 divided by 12. Okay, greater than 1.279. Okay. Right. Now this statistics is based on the assumption that the difference is equal to 0. But now we are told that it's not. The difference is actually equal to 2. Right? So what I'm going to do is the following. I'm going to subtract it 2. Right? And because I have subtracted, I need to add. Right, now in the next step, I'm going to take this term here to the right hand side. All right. Okay. Right. Now, in the next step, I'm going to use a property that I mentioned in the lectures. Namely, if you look at the video on the normal distribution, you will see the following. Right. That suppose, let me write down the property. Suppose you have two different samples, two independent samples, x11. So x11, x12 up to x1 n1. Right? This comes from a normal population with, say, parameters μ1 and sigma 1 squared. Then x21, x22 up to x2 and 2. These are all IID. IID with normal with parameters this and this. And suppose too that these two samples are independent of each other. Okay. right? So under these conditions, using what you learned in the on the video on the normal distribution, you should know that the following fact is true. That is, the sample mean of the first sample minus the sample mean of the second sample, right? Minus, right? Okay, has, or in other words, so divided by, let me write this in full instead of going step by step. Let me write this in full. Right, this guy here should have a standard normal distribution. Okay, this is a property you guys should know. I mean, I think I might have mentioned this property also when I talked about the two sample tests. So please also look at that video. All right. So I'm going to use this property in a second. Okay. So the reason I have mentioned this property is because I'm going to use it over here. What you have here is exactly this form. You have x bar 1 minus x bar 2 minus the difference in the two population means, which is 2, right? Divided by this term here, which is exactly this, right? So using this property, we can say that this probability is the probability that a normal variable, a standard normal variable, is greater than okay. Now we don't need the conditioning anymore because the conditioning has been used to argue that this has a standard normal, right? And this you can write as 1 minus the probability and this is 1 minus phi. This phi denotes the CDF of the standard normal. If you read this off the table or read it using the R software, you will get this to be equal to 0.52. Okay, so this is the probability of rejecting a null hypothesis when the difference in the population means is equal to 2. Okay, right. All right, so that completes question 1. Let's move on to the next one. So here we have two different populations again, and in two different samples. These are the sample sizes and these are the sample means. And we are told that these come from a normal distribution with common variance equal to 1.742. Right? And the first part is to test if the populations mean of the two differ at 5% level of significance. Right? Okay. Let's see how we can do this now. Excuse me. Sorry. So this is question 2, part 1. So what we are trying to test here is whether the two population means, let's call them mu A and mu B, right? Whether they are equal versus the alternative whether they are not equal. Okay. Okay. In this case, you should guys look at the. Once again, you should look at my video on the two sample tests. You will see that the rule for rejecting H0, right, is the following. Absolute sign, okay, greater than z1 minus alpha by 2. Okay, this is you should know this, guys, from the video on two sample tests. Okay. Right. Okay. Now, what I'm going to do, as usual, is to work out the left hand side and the right hand side and see how they compare. Right. So the left hand side, x bar 1 is given to us is 10.24, x bar 2 is 9.76. Sigma 1 squared and sigma 2 squared. We are told that there is a common variance which is 1.742, right? So both these are equal to 1.742 divided. Okay, the first sample is 25. All right, sample size is 25. This is also 1.742 divided by 25. Okay, and you take the absolute value of this, right? And you will get this to be equal to 1.286, right? So that's the left hand side. The right hand side is, we want the 5%, so your alpha is 0.05. So this is 0.975, which is 1.96. And clearly this is not greater than 1.96, right? So the conclusion is that there's no evidence against the null hypothesis, right? So this completes the first part. The second part is to find the probability that will incorrectly fail to reject the null hypothesis if the true difference is equal to 1. In other words, the true difference between the two population mean is equal to 1. Right? So, okay. This is question 2, part 2. So if you read the wording carefully, it says incorrectly fail to reject. What that means is that we are accepting the null hypothesis, right? When the true difference between the population means is equal to 1. Okay. Right. Now, if you go back to the previous part 1, you see that this is the rule for rejecting the null hypothesis. So the rule for accepting the null hypothesis is if you replace the greater than sign by a less than or equal to sign. Okay, so that's what I'm going to do here. So this would be the probability that divided by, we know what the variance is. So the variance, we know, so this is simply 2 times 1.742 divided by 25. Remember this, because if you go back here, the sigma 1 squared is, and the sigma 2 squared is both equal to 1.742, alright? And the sample size are both equal to 25. So this is what you have in the bottom, right? Less than or equal to 1.96, when the true difference between the population means is equal to 1. Okay. Now, to do this kind of questions, okay, the first, we have done enough questions of this kind. The first thing to realize is that we should subtract a 1 here, because this statistics is based on the fact that the true population, the difference between the true population means is equal to 0, but now we are assuming it is 1. So we need to introduce the -1 and add a plus 1. Okay. Alright, next thing I'm going to do is, before we can take this one to the right hand side, we need to get rid of the absolute signs. And you should know the following. I don't know whether you guys know this, but you should have something like this, right? This is the same as saying this, right? So if you don't know this, please try to remember. If you have an absolute value of z less than or equal to a, means that z is between -a and +a, right? So using this property, you can write the above as Alright, now I'm going to take this one here to either side, right? Okay, so this will become okay. Okay. Now, in the next step, we have this probability that this guy here lies between these two, right? And you can write it. Oh, before we go, okay, we can also do it like this. Okay, now using the property that I mentioned earlier, that I left out a -1 here, guys. Sorry, excuse me. There should be a -1 here. Using the property that I mentioned to you earlier, right? We know that this guy here, in the previous, if you look at the solution for the previous question, I mentioned a property that this must have a standard normal distribution, right? So using that, using that property, you can write this as okay. Right, guys. So now we don't need the conditioning anymore, right? The property I referred to is this one here. So this is a property I mentioned when I did question 1 of this tutorial sheet, right? So that's the property I have used to go from this line to this line, right? Okay. Now we can write this as the difference of the following probabilities. Write this now minus the probability that okay. Right, so we're not too far from the end. In the next line, I'm going to use this notation phi, which denotes the CDF of the standard normal. Excuse me. Okay, minus okay, and you have phi of a minus number here, right? And so you can use the fact, I think I mentioned this to you before, now phi of a negative number is 1 minus the phi of the positive part, right? So this would be -1 plus phi . Okay. Now you can read all these using the table or using the R software, right? So in either case, you will get the answer to be approximately equal to 0.24. Alright, so this completes the solution to question 2 of the tutorial sheet. Right. The next question is, let me take this away. The next question is question 3. Right. So here you have two drugs, A and B, right? And you want to know how they compare, I think. Yeah. So these are the statistics that you are given. The sample sizes, N1 and N2, the sample means and sample variances. So we want to see a 5% test about how the two population means differ from each other, right? So let's see how we can do this. There are two parts to this question. The first part is to test using the fact that the two population variances are not equal, right? And the second part is to assume that the two population means are equal, right? Okay. So it's question 3, part 1. So we are trying to test whether the population means are equal versus they are not equal. The difference between this question and the two previous questions is that here we don't know what the population standard deviations are. We are only given the sample variance for the first population and the sample variance for the second population. So in this case, the rejection rule will be different, right? If you look at the video on the two sample test, you will see the rejection rule, right? Which involves sample variances, right? In fact, it is the following. I will write it down. S1 squared. S1 squared is the sample variance for the first population. S2 squared is the sample variance for the second, right? Greater than in absolute value, greater than the percentile of the t-distribution. Okay, with a degree of freedom. And this probability A, I gave you a formula for A, which was really complicated. I don't even remember what it is. But this is the formula that I gave you in that video, right? All right, now let's write down what the values for these that are given to us. We are told that x power 1 is 28.2, right? X power 2 is 30.7. We are told that n1 is 33, n2 is 37, and we are told that s1 squared is 16.36 and s2 squared is 18.92. Okay, right. Now, to do this test will be complicated because of the fact that A, the degree of freedom parameter, it takes a really complex expression. Now, if you look at the sample sizes, which are 33 and 37, they are large. I mean, at least in statistics, anything above 25 is considered large, right? So you can approximate. What I'm trying to say is the following: if you an approximate test is to reject the null hypothesis if the following is true. So this should be n1, excuse me, sorry for my writing, s2 squared divided by n2. It's n1, guys, okay? Greater than the z percentile with this probability. Okay, so you see where this comes from, because the sample size is large, you can approximate the percentile of a t distribution with the normal percentile. That's one property I talked about in the video on students t distribution, that for large, as n goes to infinity, right, the students t distribution, or as the degree of freedom goes to infinity, the students t distribution approaches the standard normal distribution, right? Right. Okay, so this is the test I'm going to use, right? Okay, now let me compute the two sides of the test, the left and the right. So the left hand side is going to be x bar 1, which is 28.2 minus 30.7. S1 squared is 16.36. Okay, now if you work this out, you will get this to be equal to 2.49. And the right hand side, we are using alpha as 5%, so that's going to be z 0.975, and that's going to be 1.96, right? So clearly 2.49 is greater than 1.96. So the conclusion is that there is evidence against the null hypothesis, right? That the two population means are equal, right? So this is part 1. Now part 2, you should go back to the question, right? Is to do the same test by assuming that the population variances are equal, right? Okay, now in this case, in this case, so this is question 3, part 2. In this case, I gave you the following rule. You should remember. In this case, you reject the null hypothesis if the following is true: x bar 1 minus x bar 2 divided by SP then the percentile of a t distribution with the degree of freedom equal to n1 plus n2 minus 2. So this is the, as you may recall, if you go back to the video on two sample tests, you will see this rejection rule. Okay, now let's compute the left hand side and the right hand side. Before we do that, we need to compute SP is the pooled sample standard deviation. Actually, SP squared is given by this formula. I think I mentioned this before. Okay. Now we should put in the numbers which we know. So this is going to be 32 multiplied by 16.36 plus 36 multiplied by 18.92, then you have 33 plus 37 minus 2. Now if you work this out, this will be equal to 17.715. Okay. All right. Now let me call this equation star. Right. Now the left-hand side of star is equal to x bar 1 we know is 28.2 minus 30.7 divided by SP is the square root of 17.715, then square root of 1 divided by n1, 33, plus 1 divided by n2, alright, so this is what you get, and if you work this out, it will be 2.481. Okay, and the right hand side of star is the percentile of the t distribution, right, which is t 0.975 at 33 plus 37 minus 2. You should be able to read this off the table, right? And this will be equal to 1.995. So once again, 2.481 is greater than 1.995. Alright, so hence once again we reject the null hypothesis that there is evidence against H0. Alright, so this completes question 3. Alright, the next question is question 4. So here we have two samples from two different populations, and we want to test whether the population means are different from each other. Alright, so let's see how we can do this. So this is question 4 of sheet 12, right? So what you're trying to test for here is the hypothesis that versus the alternative that mu1 is not equal to mu2. Now let's write down what we are given in the question. So let me just kind of put this up here, you can see it. Alright, what we are given in the question is the following, right? You are told that the sample from the first population is of size 29, and the sample from the second population is of size 64. The sample mean for the first population is 9.8. And the sample standard deviation for the first population is 2.9. For the second, it is 4.2. All right. This is what we are given. Now, to test this hypothesis versus this, since we don't know what the population standard deviations are, I mean, they are unknown. What we know is the sample standard deviations. The rejection rule, if you look at the notes, or the video, or the typed notes, you will see the following formula. this greater than t with the degree of freedom given by A and 1 minus alpha by 2, right? Where A takes a complicated expression that is given in the video or the typed notes, all right? Okay, now let's see how we can compute this and this, right? First of all, let's start with the left-hand side. The left-hand side is the absolute value of 9.8 minus 11.9 divided by so this is, now if you have a calculator, you should be able to compute this, and it will turn out to be equal to 3.14, right? That's the left hand side. Now for the right hand side, we need alpha. We are told 1%, which means your alpha is 0.01. So alpha by 2 is 0.005, and 1 minus alpha by 2 is 0.995. All right? Now we need to compute the percentile of the t at this. Now, because this is a complicated expression, I mean A, the degree of freedom parameter, what I'm going to do is to use an approximation. Now you see that if you look at the sample sizes, N1 and N2, they are pretty large, 29 and 64. They can be considered large enough. I mean, at least in statistics, anything above 25 is considered large, right? So what I'm going to do is the following. So since N1 and N2 are large, right? We can approximate this percentile by a normal percentile. Okay, right. This is the percentile of the standard normal distribution. Now this is Z 0.995, and if you read this off the table, you will get this to be 2.576, right? And clearly 3.14 is greater than 2.576. So the conclusion is that there is evidence against the null hypothesis, right? Okay. Right, so that completes question 4. The next and the final question on sheet 12 is question 5, right? So here we have two populations. We are trying to compare, if you read it in full, we are trying to compare two proportions. The first proportion corresponds to those who believe extraterrestrials those who believe extraterrestrial in the population of adults who did not attend college. And the second proportion is the proportion of who believe in extraterrestrial in the population of adults who did attend college. So we are trying to compare two proportions. The first is the proportion of people who believe in extraterrestrial and did not attend college, right? And the second proportion is the proportion of people who believe in extraterrestrials but did attend college, right? All right, so let's write down what we are given. All right, so this is question 5. So let me just, so it's the proportion of the proportion of people believing in extraterrestrials, but did not college, right? Okay, that's the first proportion. And we are trying to compare P1 with P2, which is the proportion of extraterrestrials, but did attend college. Okay. Right. So these are the two proportions, and specifically we are trying to test. If you read the full question, guys, what we are trying to test is the following hypothesis. So the null hypothesis is that the two proportions are equal. And the alternative hypothesis, whether the first proportion is less than the second proportion. That is, the proportion of people believing in extraterrestrials, but those who did not attend college is less than the proportion of people believing in extraterrestrials but did attend college. Okay. Now, if you look at the video or the typed notes or the handwritten notes, you will see the following, right? The rejection rule for the null hypothesis is if the following is true. All right, if this is greater than minus of z1 minus alpha, right? This is the rule I gave you in the video and also in the typed notes or the handwritten notes. All right. Okay. All right, now I'm going to compute the left-hand side and the right-hand side and see how they compare. Before I do that, let me write down what is given to us. X bar 1 is the sample proportion corresponding to the first population, which is given to us as being equal to 37 by 100. X bar 2 is the sample proportion corresponding to the second population, given to us as this, right? N1 is the sample size for the first population, sample size for the second. They are both the same. All right? Okay. Now let's compute the left-hand side. If you put these numbers into the left-hand side, this is what you will get. Okay? Let me put them. All right. This 37 divided by 100 minus 47 divided by 100 in brackets. Right. Okay. Divided by 100. Okay. The square root applies to the whole thing. Right. Now, if you compute this, guys, you will get this to be minus 1.433. So that's the left-hand side. Now, the right-hand side. The alpha, if you read the question, is 5%, so alpha is 0.05, so Z 0.95 is equal to minus 1.645, right? So what you see here is that minus 1.433 is indeed greater than minus 1.645, right? So the conclusion is that there is okay. So in other words, there is evidence to support that the proportion of people believing in extraterrestrials but did not attend college, right, is less than the proportion of people believing in extraterrestrial but did attend college, right? Okay. Alright guys, so that completes question 5 and also completes the video solutions to tutorial sheet 12.